Welcome to subduction zones and orogenic processes. We will build an intuitive picture of how convergent margins make mountains. At a subduction zone, an oceanic plate dives beneath an overriding plate. The downgoing slab bends into the mantle, creating a trench at the surface. Material is scraped off to form an accretionary wedge. Above the slab, fluids rise into the mantle wedge and trigger melting. Feeding a volcanic arc landward of the arc is the back arc region. Let's highlight each part one by one. Why is there so much volcanism here? As the slab descends, hydrous minerals break down and release hot water-rich fluids. These fluids rise into the mantle wedge, lowering the melting point and producing magma. The magma ascends to feed the volcanic arc, adding new igneous material to the crust. Convergence compresses the overriding plate. Thrust fault stack slices of crust, thickening and uplifting the margin, while continuing arc volcanism builds high peaks. This is the essence of Cordilleran-style orogeny. At the trench, the accretionary wedge grows by scraping off sediment at the front and by underplating slices at the base. Here is frontal accretion, and here is basal accretion, adding a slice underneath. Subduction margins vary through time. If the trench retreats, the back arc can stretch and even open a basin. If the trench advances or coupling is strong, the back arc is compressed and thickened. A classic example is the Andes. Oceanic Nazca Plate subducts beneath South America, driving shortening that exceeds 200 kilometers and building a crust up to about 70 kilometers thick. Segments of flat slab reduce volcanism, but increase inland shortening and uplift. Subduction creates high-pressure metamorphic rocks at depth, blue schist forms at moderate depth, then eclogite deeper. In continental subduction, ultra-high pressure rocks can form and later return toward the surface. Summary: subduction zones build mountains by a combination of tectonic shortening and magmatic addition. The accretionary wedge grows at the trench, the mantle wedge melts to feed a volcanic arc, and the overriding plate thickens by thrusting. Depending on slab dynamics, the back arc can extend or compress. Subduction orogens, like the Andes, show that sustained convergence alone can create thick crust and high plateaus.